is our today's speaker, James.
Hello.
Yeah. And if you need water, there is a tank there and the cup there too. Yeah. And you can have some any snack you want in that room. Yeah, we have lots of food and Coke. Yeah. So that's all. And welcome to our speak.
So the first thing I'll say is that if you're interested in the things I'm talking about, because there's lots of links in my presentation, I put the link to the presentation here and the tutorials that I'm going to share. So afterwards, if you want to see his code, these things would be to go to the website. Okay, so I am James Haber, and I work for a company called Cloud Technologies. It's located in Oklahoma City in the center of the US, but we have a half remote, half local development team. So there's about 4 of us working remotely and 4 of us located in Oklahoma City. So we mostly use Haskell for our production code, and I want to share some of our experiences using that. So our main product is OnPig, and what are we actually doing? So we're connecting to machinery that is being run by PLCs. So you might not have heard of a PLC. It's a programming logic controller. You can think of it as a very sturdy microprocessor. So it's meant to be put out in the field in various weather conditions, and it can help run machinery. So it's a very sturdy device. So if I'll go to the main website, and sort of, you can see some of the stuff, like what some of the stuff looks like. So basically what we're trying to do is communicate to these machines and collect data from them and then bring it back to our customers and allow them to see that data and see what's going on. So most of the people we're servicing are oil fields, solar panels, water treatment facilities, and farmers as well. So various types of machinery is being powered by PLCs. And we communicate to these machines via protocols we've written in Haskell. So, and so I guess a bit about the code base history. I want to get into why we decided to use Haskell. What's the motivation for using it? So the company started maybe 5 or 6 years ago, and the original code base was written in PHP and C#. So the advantage of C# is it has a lot of libraries, but we ran into a lot of support issues from Microsoft. So often, if we ran into some sort of compile issue or something like that, their answer was, well, use our newest product, which might mean abandoning our current code base. And that sort of doesn't feel too good when you put that much work into it, and you sort of worry if the next how long the next version of the code base will survive. And I'm sure most of you are familiar with issues in dynamic typing, and this is a serious issue in PHP. So we had a lot of issues with that. So because Scott, the boss of the company, was already familiar with Haskell, he decided to transition the code base to Haskell, and that started about end of 2012, and we hired, the first Haskell hires were in 2013. So if you've used Haskell, I'm sure you're familiar with the motivations for using it. You can eliminate certain types of bugs. They get a lot more things get caught at compile time. We have access to great testing libraries like HVEC and Tasty. There's a small but strong community online with whom you can converse if you have any problems. Usually, there's a lot of Haskell users that are happy to help. And another thing that I find interesting is I feel it's sort of on the cutting edge of computer science and these other areas of math that relate to programming languages. So for example, I believe applicative functors were discovered through the use of Haskell, and if you're curious about that, this paper sort of discusses that. So the situation with Haskell isn't perfect. There's a lot of challenges when trying to use Haskell in production code. So the first problem is, since the main component of our software is that it can communicate with these various machines, well, there's a lack of protocols written in Haskell, basically almost none. So we had to make all those on our own, and protocols being the protocols speaking to these machines, which each machine may have their own protocol, and often they have manuals that describe how the protocol is implemented, but sometimes those can be hard to access if it's an older machine. So at the beginning, when in 2012, when coding was started in Haskell, build systems were still a challenge. I believe there weren't Cabal sandboxes at the time, so you had issues with handling global packages, and there are lots of conflicts with that. But in the last few years, that's improved a lot with Cabal and Stack. So it's made pushing code to production a lot easier. And another issue was thin talent pool. This has also improved recently, but it's still hard to find a lot of people that are experienced in Haskell because there just hasn't been a strong demand in the industry over, say, the last 10 years compared to other programming languages. And there's clearly a steep beginner's curve if you are not familiar with functional languages, but now there's a lot more resources available. So a bit of an overview of the things that we are using in OnPing. So probably on the user face, the most apparent thing is Asode. It's a web development library. It's pretty popular, and it's paired with Persistent, which is a sort of database interface for Mongo, SQLite, MySQL, and Postgres. So we're also using Docker to manage our databases, and we use Angular on the front end, and we're transitioning that to GHC.js because we can reuse a lot of the code that we've made for the front end. And we are doing a microservices architecture, so I'll explain a bit more about that, but we're using Servant to handle that, and we have our own private package to manage those packages. And we're in the process of moving to Stack, but we're still using Haskell at the moment. So this is unfortunately this is a little small, but this is one of our main packages, and the idea here is just sort of to show how many dependencies it has. So this is sort of ties into the microservice idea. So at a lot of these endnotes here are individual servers that are specialized in what data they provide. So from the main Asode app, when there's a query is performed, it may query one or more of these servers. And so the way we've set it up is communication to these servers as a sort of type-safe guarantee provided by Servant. So I'll get into that more. So basically, microservices are they're sort of like processes, but they communicate over a network. Instead of existing locally, they exist perhaps in another server and need to be communicated in that way. So that you can sort of build these small, lightweight protocols, and it decreases coupling to your main app. And then you can organize these microservices around certain tasks. For example, something around front end, around a search engine, around an accounting system. And so we mostly use it for database and protocols. So for one particular machine, we will develop a protocol, and we will store that in its own server because it needs to communicate with other machines in the field. And we can sort of just if there's any issues with a particular protocol, it's easier to find that instead of if it were in one monolithic app. And so there are a few drawbacks from using a microservice architecture, which include testing and deployment. So in a monolithic app, it's a lot easier to test because you have, well, theoretically, it's a lot easier to test because you have all of those tests in one area and all your code in that area. But now when you have microservices, you need to set up a lot more config files. You need to tell your main app where those services are located. So like if you have, like we have a lot of microservices, so we have many YAML files which have information of where they'll find those services. And this obviously makes deployment more challenging as well. And then you have some issues with network latency and how you're formatting your messages. But for us, the message formatting is an issue since we've done that all through servant. So I want to talk about the libraries that we're using. So the first one I'll talk about is servant. So it's you can basically make a type-based API. So what this means is you declare a type with a number of get, post, delete queries that you need to implement on the server and on the client. So on the server side, you'll be responsible for building handlers for each of these queries, and that may involve getting data or changing data. And then on the client side, you need that's just where you're creating an interface to actually access that data. So then on the client side, you decide when you want to get that data, and then you leave all the then you pass off that to the server. So the way we use it is we're mostly using JSONs to communicate back and forth. So if you've used Haskell for any sort of web development, you've probably heard of ASON. It's a popular package for handling JSON data. So if you want to know more about that, you can follow this link down here. So I want to talk about the way we set up, the way we set up a microservice. So usually for one service, we'll have 3 packages. So the main package would be a type declaration. So this is where we declare the API. So let me show you that. So here, that's pretty small. Unfortunately, you can't see that, but there's 3 packages here. Okay, so here we have an API, just a really simple API. So this test API requires you to implement 2 things: a function, a post function. So you want to be able to post a user, and it'll give you a user ID, and then you can get that user by its name. So where's this user coming from? This is persistent. It's a database package that sort of comes with YASA, but it allows you to use quasi-quoters, which are these, if you're not familiar with quasi-quoters, it's these square brackets tell you you're in a quasi-quoter. So this has its own syntax rules. You can sort of define your own DSL. And so you sort of have this, if it's aligned to the left, that's sort of the table name. And then each of these rows could be like an individual row of a table, and then the type, and then a uniqueness constraint, and it's deriving various type class instances. So what does this actually do when you run it? It provides a number of, it'll automatically give you this set of functions and types. So you'll end up with a user type, a user ID type, a key user, which are the same thing, and then So I have this name, I have this up here, I have this name and this age row in user. So if I get a user back, I can just, it'll have two fields in it, user name and user age. So a simple product type. And then I'll give you, and then here I'm deriving from JSON and to JSON. So sorry. So if we look here, so in the request body, I need a JSON of a user. And then in the return body that we get, I'm going to get a JSON of a maybe user. So this little package just has the declaration of the models that we want to be able to, that we want available in other packages, and the API declaration. So let's take a quick look at the server. So I'll skip over some of the details. If you're not familiar with Servant, there's really good examples of it online that will help you get started. Or you can use this one. So basically, I'm creating two handlers, a user add handler and a user get handler. So basically, right here at this user name part, I'm selecting the first user that has this name that's passed through the API. And then, I'm sorry, this is at the user add. So I'm looking if the user exists before I try to insert it. So if the user doesn't exist, I insert it and I return the key. And if it doesn't, I just return nothing. And then this is the user get. It'll retrieve the user by name and send that back. And so this is just some more information. It's running on SQLite, and it uses port 3000. So that's, and then here's a simple client. So here I'm just a bunch of settings, and basically what I do is I run this queries function, which has information of which server it's communicating with, and it's going to add a user with name Alice, age 26, and then it's going to request to get the user Alice. So I'll start the server here. So it's running. And then this is the test client. It just makes a simple query. So you can see we got a user backed new house. And then you can see that queries were made in SQLite on the server. So does that make sense, or are there any questions regarding that? Yeah. This part is just servant.
Oh, so we use server and persist.
Yeah.
Without use of the whole
Yeah.
server.
Yeah. So this small example is just servant and persist. Okay, if there's no more questions, then I'll move on to the next thing. Okay, so actually I already went over persistent, but I'll go over Haskell. So Haskell is a caching library. So what it does is it helps you cache queries. So there's some instances when you want to make some pretty complicated queries, and it could come from multiple sources. So Haskell gives you a way to generalize those queries. So you, for example, you could need something from a file, or you need something else from like a servant server, and then something else from a local database. And maybe you're accessing those multiple times and putting together a complicated type. And so you want a way to, one, generalize those queries. So sort of on the code where you're actually building those, putting together those data types, you don't want to have to worry about where is this piece of data coming from. You want to make it simpler. And also, if you're repetitively accessing the same data, you want to be able to cache that to save you, so you don't query the same, make the same query for data you know that hasn't changed. So Haskell doesn't actually provide cache invalidation, so you have to make that yourself. But it's, I mean, I've added that to a simple example. It could get complicated if you have a more complex backend, but it's still valuable even if you don't have cache invalidation, if you're doing complicated queries. So Haskell is actually made by Facebook. It's something they use internally, and then they open source the code. So I'll sort of add an example for that. So it's actually using a similar model as I just showed you. So it's also this simple user model. And I want to be able to do queries. So there are a number of data type. So here you're sort of declaring the query, your Haskell queries, the types. So here you're going to, get user and tell it what you're giving it and what's coming back. And then since you're doing some sort of caching, there's this type class called hashable, which will take a type and then turn it into a hash key. So let me show you what that looks like. So here I have it just derived generically. Sometimes you have to derive it by hand, but for here, I have various instances of hashable, so I can actually use it, so I can have a hash key for a particular type. So, so probably the main area of code is down here, and I won't get too much specifics of it, but basically you need to tell Haskell how you want to access that data, like where is it coming from, and how to handle synchronicity. You can actually do it synchronously or asynchronously, and so it has some ways to handle blocking. And then finally down here, this is sort of similar to what I was doing in Servant. So down here I have these 3 queries, and I tell Haskell how that data is accessed. So when any one of these is run, it'll cache that data. So assuming you don't invalidate the cache, this will only get run. Each of these would only get run once if you don't invalidate the cache. So, and here I'm just simply emptying, like so if you change a user, if you insert a new user, in that case you would want to invalidate the cache because you want to be able to access those new users. And so here in the insert user function, I'm just invalidating the whole thing because it's a simple example, but the cache is basically like a hash map of some sort. So you could come up with a way to only invalidate the pieces that are being changed. So let me show you what that sort of looks like in use. So for this case, I'm just using SQLite, and then I insert a user, I make a query, and then I insert 7 more users, and then I run this query 3 times to sort of show that, just to sort of prove to you in the example that it's being cached. This is a bit of a mess. So here you can see that the database is being created. And then here I want to insert a single user. So wherever you see the debug SQL, that's where an SQL query is happening. And then I run a single select. So this is the item that I get back. So you can see I inserted 1 user, and then I requested it, and I got a single user back. And then I insert 7 users, so lots of queries there. And then I run the select query 3 times, so I want to get everything 3 times. So here is the set of queries to get all the users. And then it's actually in between this, it's running Haskell 3 times, but SQLite isn't requested again. It's been cached in Haskell, so it doesn't need to perform that query again because we haven't invalidated the cache. The cache is still valid, so we can still get the data because we're giving it the same hash key. So sort of so this is pretty similar to the other example I showed as servant, but the cool thing is you can put a number of things behind Haskell. So you could, in this example I just put SQLite, but I could put SQLite and multiple servant clients and file access, and then just use this function right here. So where you see this run Haskell environment, and then this get all users. So this is sort of these Haskell queries that I've made. So from the point of view of the sort of client code or the handler code, you don't really see what's going on behind this get all users. So at this point, I'm not concerned where that data is coming from. So it's sort of a nice way to hide all of that data, or hide those queries in one place. Are there any questions regarding that?
Yeah. So how do you handle cache invalidation?
Well, for what we're doing, we're not really using the caching, the cache beyond single sets of queries at the moment, because we have some pretty complicated queries where it goes from, we request data from multiple servers and then put it together. So really, we're not we don't have enough users to worry about that right now. So really the huge value, the huge value right now is the cache in those single large queries, and also the unification of all those queries in one place. Any other questions? Yeah.
Yeah, what happens when Haskell runs low on memory?
That's a good question. I don't have that answer. Okay, so anyone else?
So it's basically a proxy, and you use that in every place that you need to access or rewrite the data.
Yeah.
Okay.
Yeah.
Just so it will be invalidated if you use it to set some data to the actual DB and of course for the cache itself.
Mm-hmm.
Okay.
Anyone else? Okay, the last bit of code I'm going to talk about is GHCGS. So GHCJS is a compiler from Haskell to JavaScript. So I guess why would you want to compile Haskell to JavaScript? Because you like all the nice things you get from Haskell, all the type safety, and you want to sort of treat JavaScript as bytecode, as sort of as compiled code that you don't really want to look at. Because JavaScript doesn't have all those type safeties, and you want to stay in the same language. So some of the nice things that GHCJS has is it supports template Haskell, it supports Cabal and Stack, but there are a few things, and it does support a lot of the libraries out there. So a lot of the libraries you find on Package, you can use a good percentage of those libraries. I'm not sure how many, but probably a few things to watch out for are networking libraries, because you're most likely to be running GHCJS on the front end, so in a browser. So you sort of have to think about how does a browser handle networking. So you have issues with cross-domain, things like that. So because of this, we had to make a fork of GHCJS. We had to make a fork of servant client, so we call it GHCJS servant client. So it basically helps you get around a few of the networking assumptions that the servant client makes. So basically, how we have it set up is we have a number. We're only using servant client from GHCJS to communicate to our Yasad app. We're not communicating to our other servers that are using servant. So if the front end wants something from one of those servers, what it does is it makes a request to Yasad, and then Yasad in one of its handlers will use Haskell, and then it'll make a request to one of those servant servers. So that way we don't have to deal with any cross-domain issues, and it's sort of nicely hidden and maintains a nice hierarchy. So we currently, in production, we currently just have one area of our code that's using GHCJS. So it's definitely still in development. Like, it's usable for production, but you have to be willing to dig a bit deeper to get it going. So, and it's improving, but it still makes large files. So I believe our last project, like after it's compiled with GHCJS servant, with GHCJS, it's probably like 4 megabytes, but you can use the closure compiler on that to remove unused code, and I believe it brings it down to 2 megabytes, which is still pretty big if you are concerned about, if most of your users using it on a cell phone, that's still a big concern. But since we're doing more B2B and it's a really specialized sort of area, it's something we can make that sacrifice in order to improve development time and catching bugs, things like that. So we have a package called Live VDOM, and if you're familiar with VDOM, it's sort of like a DOM differentiating library. So basically the idea is you would only chain, if you have some sort of events that may change the DOM, you only change the DOM if it's actually different. So if the event has sort of actually caused a change to the DOM, you only change it at that point. Because this is sort of, if you're familiar with React or some of the newer JavaScript libraries, it's sort of a popular method to handle it because it's quite computationally it's quite expensive to make changes to the DOM. So you want to reduce that as much as possible. So we use a package called GHCJS VDOM, which is basically a front for it connects to the JavaScript VDOM library. And then we actually write most of our code in a quasi-quote that we made called Valentine. So I'll go ahead and show that to you now. So here, this run tasks is like the main function. And then we have this DOM here, and it runs this function called display tasks. And then this display tasks basically takes a task type and a string. So I'm ignoring some more of the details. Basically, the task has some details, some text, and then whether or not it's completed. And so here's really the interesting part is this Valentine quasi-quote. So if you've used Jasad before, it has a quasi-quote called Hamlet. So this is sort of a branch off of that. We've made some of our own elements. So this looks very much like HTML. But then we have, wherever you see these symbols and the curly brackets, that's where some live VDOM code is happening. So basically, when you see this for each, this means this section of the DOM can change. So whenever a change happens on this task, and this display task function will be run. And basically, all it does is it adds a new div. So I'll show you what that looks like. The code, it's not too exciting. So this is after I've compiled it, and I'm just running it in my browser. So basically all I can do is add tasks. So this is all done in GHCGS. I haven't touched any JavaScript code to make this. So any questions about that?
So do you implement any web API for your VDOM, because the React's VDOM has wrapped the front-end API for their attributes?
Yeah.
Yeah.
We're just using we're not using React, but we're using sort of the VDOM library that gets used in React.
So your VDOM object has some attributes like React's VDOM has.
Yeah, I'm actually not familiar with React, so
Okay.
So I don't know the details of how React works. I just know it uses the VDOM. So
what I mean is the VDOM actually wrapped the DOM API. Like the DOM API has get an element by ID, so they implement their own for the VDOM. So I don't know, because it's a very huge effort for you if you want to do the same level VDOM like they did.
Right, I would assume that's been done. So we are using a package called GHCGS VDOM, and we worked with one of the maintainers of GHCGS to create it.
So maybe they did some part of.
Yeah, let's see. So here's one of the packages that we're using. This is the VDOM package. So yeah, I mean, if you're curious about it, you can take a look. I don't know. I wasn't the one that implemented the live VDOM stuff. But
Okay.
I assume, yeah. I mean, I assume it's similar, using similar ideas as React to get that working.
So another question is, what's the major difference of Valentine and Hamlet?
Major difference between what?
Valentine and Hamlet.
So in Hamlet, basically, when you have like the curly brackets, I believe everything has to turn into a string when it gets compiled. But what we have in Valentine is that code could be dynamic code, so it could be like sort of like a JavaScript event, and then it could create DOM dynamically.
So
So
it's
sort
more
of-
flexible and it's suitable for the case you show.
Right.
Yeah. Okay.
So Valentine Live VDOM is sort of what, like, our framework for creating the front-end code.
And I believe you write no front-end code for your product with all these things.
If you don't use those things, then you'll have to handwrite a lot of like repetitive code. So I think they have some examples here of sort of what that looks like. Yeah, so this is without any, this is just like GHCGS. They're not using any outside packages.
Yeah.
So you can see it's very similar to the way you write JavaScript code.
Yeah.
So you have like this
The thing
document.
annoying don't name API.
Yeah, so you don't really, you get the type safety, but you're still you kind of feel like you're still in JavaScript.
Yeah.
So it's not that exciting. And if you look at just the imports, it's just so very large. Lots of stuff.
Okay.
So we try to hide some of that with the package.
Yeah.
But if anyone's sort of interested in these things that we're using and working on and wants to try to adopt that to your own project, feel free to contact me and I can help you out. So, so that was sort of about all I had to talk about. Thanks for having me here, and feel free to ask any questions. Yeah.
My question is more to do with the social aspects of your company.
Yeah.
You mentioned that you have 4 members of staff in the US, and 4
Right.
members of staff working remotely.
Yes.
How do you deal with different issues such as time zone issues and
Right.
keeping in contact with yourself?
So we mostly use Slack for communication, and we do bi-weekly meetings. So we have, our team is composed of 4, so I'm in Taiwan, we have another developer in Malaysia, one in Spain, and then one elsewhere in the US. So we sort of found a time that the 4 of us plus the rest of the team in Oklahoma can meet, which is generally in the evening for myself. And then we do sort of like daily emails saying what we've done during the day. And on Slack, we sort of leave messages for each other. We have different rooms, and we try to get back to each other. But we sort of have it set up like everyone's working on one piece that sort of fits together. And so like I'm sort of responsible for a certain set of packages, but it's definitely possible that other people be working on those packages. And we heavily rely on Git branching, stuff like that. And sort of, I feel like the sort of type safety guarantees you get from Haskell definitely help with the remote team, because if someone's made another package you've depended on, and there's been like a type change or the change in the function, it's not gonna, it most likely won't compile. So you'll sort of get notified, and then you'll realize, okay, I need to go look at what they've done and figure out how that affects what I'm working on. And I've actually done remote work for about the last 4 years. So I've been with this company for about 2 years. So it's sort of, I think every team has a different way of handling it, but similar recurring things. Definitely have to focus a lot on how you communicate. So writing skills are very important. So because we're not necessarily communicating a lot in person, but most of it's in writing. So you really have to think of how, like, what you're trying to do and how you want to express that. But I think the advantage of that is spoken communication. It's sort of at the moment, like you have to respond quickly, but when you're writing, you have a lot more time to think about what you're trying to say. Yes?
Maybe if I just can add to that question. So are you additionally using something like Jira or ticket tracking, or is it then really interpersonal via emails, or like what you're going to do next?
So at the moment we're using GitHub issues. So we actually just have one package and we call it issues. And we put, what we do, because I think the way GitHub has handled issues is a little bit messy, like if you have many packages. So the system we've come up with is basically you put the name of the package in the title, and then the error, or the issue, and then you sort of tag the people that are involved or who you want to look at it. So that's been a really good tool. I mean, I know there's more. There's probably. I'm not that familiar with Jira, but I know there's probably better solutions out there. But it's just sort of what we've ended up at this moment. And also one thing is we sort of use, because some of the clients, like we want to allow the clients to be involved in it a bit, because some of our clients are technical, more like on the engineer, like more like in the field engineering, but they still have a bit of idea what's going on. So we use groups for some clients that want to be more involved. So if we want to allow the clients to make their own issue, they can do that, or we tag them on certain issues that are related to what they brought up, so they can see certain issues.
Yeah, that makes sense. I was a bit curious, as you mentioned, like sometimes you put things together and then it might break, like the integration. Like
yeah.
Who broke it? And that I think is just really interesting, especially if it's so distributed. And then how do you still get a release at some date, right? Because every time the sun is over somebody else's head, and then do we ever get a stable build?
Right. So we're for builds we're using Circle CI, and so that sort of will run all your tests. And so how we've had it, we sort of like have like a test server. So what we do is like in the main core package, like if you change the master branch and all the tests pass, then it'll automatically deploy that to the test server. So you can sort of see that. And we have a guy that's specializing in like deployments and DevOps, that sort of thing. So we sort of, whenever we make a change and it's been okayed by everyone else, then we talk to the DevOps guy and we say, hey, we've got this change, we want to get into the production. And so he sort of acts as the gatekeeper in a way. So once we sort of go through him, we say, we put in testing, we think it looks good, it's passing all our tests, and then he'll give it another look and make sure, because, especially when you're dealing with front-end stuff, it can be really hard to catch all of that in testing. Sort of UI tests are very challenging and still an unsolved problem in some ways.
So you mentioned that you need to adapt the industry protocol with your own library.
Yeah.
So I don't know whether you need to work on the industry machine to make it like adapting Haskell on the actual machine, or you just adapted the network, the message from network from that machine? Right.
So what we do is the message to the machine. So we have someone that has more of an engineering background, and the boss taught him Haskell, and what he does is he works with the protocol with the machine. Like essentially they'll have a machine in the office, and the best case scenario is you have a manual and it tells you what the protocol is, and they've done a great job. But that's sort of not always the case. So sometimes I have to like spend a month like poking the machine, testing various things, and maybe reading byte code, trying to figure out what's going on, and then translate that protocol into something, and then communicate with that via Haskell.
So there will be a emitter in Haskell, and there will be receiver in your server also in Haskell, and there will okay, the protocol
Right.
is on the network. Okay.
Right.
Yeah. So I think this will involve some very low-level Haskell programming skills, right?
Right. Lots of byte-level coding, but
Oh,
I believe Haskell handles that quite well.
I have only seen one case is about the assembly monet, but I don't know the detail.
Yeah.
Yeah.
Yeah, I personally worked mostly on some of the stuff I spoke about here. So mostly like the database code, the front-end code, the handlers, and then we have some guys specializing in more engineering-oriented problems.
So, by the way, have you ever encountered any issue of performance from Haskell memory or memory leak or GC issue on things so far?
Yes, we have. Particular things, simple things like lists don't have very good performance, so it's better to use vectors, and then sort of like using things like sets instead of lists if you have uniqueness constraints. So there have been issues with performance, and we do have one guy that's very good at figuring out those. But yeah, a lot of like the database stuff, generally okay, not too bad. But yeah, some of our more specialized servers, we've had some performance issues.
How much machines of the queries they make you're collecting every day?
How many queries do they make each day?
Yeah.
That's not something I have offhand, but if you're curious, I can get back to you. Yeah.
To do with the recruitment, you mentioned that the difficulty of finding people who have experience with Haskell out in the world.
Yes.
Did everyone who came into your company already have experience with Haskell, or did you hire people who had a previous software engineering background and get their position?
Yeah, that's a good question. So it's been about half and half. So for example, I had just all my experience in Haskell prior to working for Cloud Technologies was just sort of my own curiosity. So I didn't have any professional experience with it. But last year we hired an individual who had a background in statistics and was also sort of like a self-taught programmer. And we hired him, and he had no knowledge of Haskell, but I spent a lot of time teaching him and sort of sharing resources and communicating with him. And now he's a few months ago he started like his very own Haskell project. So he's sort of been able to touch like the Assad code without too much difficulty, because it sort of has a very imperative feel to it. So it's not too challenging to go into something like Assad. But now he's starting his own project, and it's taken a while to get there, but I think he's really enjoyed it. So I think if you find someone with sort of the hacker mindset, or someone in a software developer or computer science background, I don't think they will have too much trouble catching up. So I don't really think you necessarily have to have a requirement that someone has to have a background in Haskell before joining, unless you are looking for someone that's like, gonna dive into GHC and say, like, why is this working poorly? So it sort of depends on what role you're trying to fill. But I think if you're doing particularly web development, it's relatively easy to get started in something like Haskell. Any other questions? Okay, I guess we can go on to the next one. Do we have another speaker time?
Okay, let me just take a step first, and people can communicate freely. Yeah.
Okay.
Thanks, James.